So in this lesson, we are looking at different triangle centers. There's a couple different ways you can find the center of a triangle. So we're going to be able to construct them and explain what they are. We're going to be, we need to know it because, number one, it's good practice with your compass and straight edge, which is kind of an important thing that we've done lots of work with, and it's just going to make that better. But knowing how to construct them is also going to help you have a deeper understanding so you can apply it better. So when your construction is good and it satisfies all the properties and you found the center, you know you got it. So first of all, the word concurrent just means that they intersect at a single point. 3 lines. Nothing special about 2 lines intersecting at a single point. That's nothing special. 2 lines always intersect at a single point. But if you can add in a 3rd line that also intersects at that same point, that's pretty special. It's different. Doesn't happen all the time. And then that point where they intersect is called the point of concurrency. So here's an example. That's the point of concurrency. All 3 lines intersect at one point. This is an example of where they are not concurrent. They don't intersect all at the same point. They intersect all over the place. It makes a triangle if you extend it out. An angle bisector cuts the angle in half. Bisect means cut in half, so it cuts the angle in half. So if you're doing that in a triangle, it goes from one of the vertices, and it cuts the angle in half. 2 congruent angles. When you do all of those angle bisectors, you find the incenter. So that's one of the centers that you can find in a triangle. If you do all the angle bisectors, you find the thing called the incenter. So to construct an angle bisector from back in unit 1, if you're trying to construct an angle bisector, you pick an angle and you make an arc. And then from each of those 2 points that we just created, from those 2 points, you're going to do kind of the same thing. You're going to try to make an X out here in the middle. That's going to show you where your angle bisector passes through. So get your compass on that point we just found. And do the same thing from down here. So there's our little X. That means that this segment from the vertex through that X, that's an angle bisector. We just did that for one angle. Triangles, tri means 3. It's got 3 angles. We got to do it 3 times. So we just did it for the first one. Now let's do it from a different angle, the top one this time. So put it on your vertex. Make your arc. And then from each of those points, you're going to make your X. So now I've got the benefit of having multiple colors here so I can see where my X actually is. There's still a third angle we need to do this for. I'm going to use a third color to help me out. So you make your arc, and then from each of those points, we get our third and final angle bisector. And if you look, now you can see all three of those angle bisectors intersect at the same point. Right there, they are concurrent, so they intersect at the same point. That point that I just labeled purple here in the middle, where all the angle bisectors intersect, that is the incenter. So incenter is angle bisectors. Perpendicular bisector. If you do the perpendicular bisector of a triangle, it goes perpendicular to the side and intersects the midpoint of that side. So it has to be the midpoint and it has to be perpendicular. So there's a perpendicular bisector for a triangle. Construction, which we're about to do, is that football-shaped construction. We're going to do that on all three sides of the triangle. And we'll draw all three perpendicular bisectors. They will intersect. They'll be concurrent. So that football-shaped construction. So we get our compass, and then on each side, we got to stretch it more than halfway. I'll do red first. And then when we do that, it's going to create the circumcenter, where all three perpendicular bisectors intersect. So take your compass, stretch it more than halfway, so we can do that football shape from each vertex. We'll do it from this left side and the right side. There's one segment, one perpendicular bisector. Now we'll do it on the left. That gives us our second perpendicular bisector. And now we got to do it on the third side. We did the bottom, we did the left. Now we got to do this one that's kind of on the right. Make sure you're more than halfway. I don't know if I need to stretch that further. I think that's okay. You can stretch it further if you're not sure. There's our third perpendicular bisector. And again, all three of those lines, they intersect at one point right here. They are concurrent. It's special. Three lines don't always intersect like that. and that's called the circumcenter. So here's the cool thing about the circumcenter, and I'll go back and show you the same thing about the incenter. Circumcenter is the center of a triangle that you can use to draw a circle around the triangle. So using this as the center of the circle, you can make a circle, go out to one of the vertices, and it actually touches all three vertices. That triangle now fits perfectly inside that circle. That's the point of the circumcenter. So if you drew a circle around that triangle that touches all 3 points, 1, 2, 3, that's the center of that circle that's going to do that. Now, the incenter is actually kind of the same thing, but different. It's the opposite. In means the circle is going to be in the triangle. So it works the exact same way, except this time instead of the circle going around the triangle, the circle goes in the triangle. So if you use that as the center, you can draw a little bit off. Using that as a center, you can draw your circle that fits perfectly inside the triangle. So, in center, the circle goes in the triangle. Circumcenter, the circle goes around the triangle. So the third thing that we can do, the third type of line we can draw in a triangle is the median. We're going to do a little bit more work with medians. Medians connect the midpoint to the vertex that's across from it. It goes from the midpoint to the vertex across. So it's actually the same construction, but you're looking at different lines. But you do the same construction because you got to find the midpoint. So you're going to do the football construction. And if you connect all 3 medians, they will also be concurrent, and that point is called the centroid. So you construct the perpendicular bisectors so that you can find the midpoint, connect the midpoint to the vertex. So the construction for the centroid is pretty much the same thing that we just did, because we got to find midpoints. So we're going to stretch our compass from each vertex more than halfway, do that football type construction. Now we don't need the line, we just need the midpoint. So use your straight edge to line up with those 2 points, but you don't need the whole line. You only need that point right there. So once you use your straight edge, you can move your straight edge out of the way and just keep the point. The line that you draw, you go from that point, the midpoint, and you just draw the line that goes to the opposite vertex. That's the line that you keep, from the midpoint to the opposite vertex. That's the median, because these sides here are congruent. So now we can do, for the left side, we're going to find that midpoint. Make sure your compass is more than halfway. Could be a lot more than halfway, could be a little bit more than halfway. Make your football type construction. And then use your straight edge to find the midpoint. And then use that midpoint to draw the vertex, to draw the median. Because these sides are congruent. And if we do that with the third side, make sure your compass is stretched more than halfway. Do it from both vertices. Use your straight edge to find the midpoint. Again. So there's the midpoint. These sides are congruent. The line that we draw goes from the midpoint to the opposite side, the opposite vertex. And then again, all three lines. They are concurrent. They intersect at the same point. If they're not concurrent when you're doing this construction, you messed up a little bit. Your compass must have slipped or something if they're not concurrent for all three of these constructions. So that finds the centroid, which doesn't have anything to do with circles. It actually has to do with the center of the triangle regarding like the balancing point. If you had a triangle with the centroid marked on, like an actual physical triangle, maybe it's like a triangular piece of tile or something like that. You put your finger on the centroid, that's where it will balance. It's the center of mass of balance right there. So the other thing that it does is it splits it up into a ratio. There's actually a formula. If you know the coordinates, there's a formula to find the centroid. So if you've got three coordinates, x, y, x, y, x, y, pretty easy formula. It's the average x plus x plus x divided by 3. Y plus y plus y divided by 3. There's a formula to find it if you know all the coordinates. That should remind you of the midpoint formula, kind of, except it's divided by 3. And there's 3 points. So it's like the midpoint, the middle of all three coordinates. So let's use that formula. It's pretty easy. You take all your x coordinates. So you take x plus x plus x, and you're going to divide those by 3. Add them up, divide them by 3. -9 plus -6 plus 0 divided by 3. So you get -5. -15 divided by 3 is -5. Then you do all your y coordinates. 7, 1, and 4. 7 plus 1 plus 4. And you divide that by 3. That's 8. 12 divided by 3 is 4. That's your centroid. Pretty easy formula, just like midpoint. Midpoint would just be x plus x divided by 2 and y plus y divided by 2. The centroid is for 3 points because it's for the center of the triangle. Midpoint's just the center of those 2 points. So that's why it's a similar formula. So the altitude, it's another line that you can draw. Altitude's the height. Just like if you're in an airplane, they'll say we're cruising at an altitude of 7,000 feet. That's the height. That's how high up the plane is. That's the altitude. Altitude is height. And height is always measured straight up. So if you're measuring the height or the altitude of a triangle, you go straight up from the bottom. You go perpendicular to the bottom. And there are 3 altitudes for every triangle. Because there could be 3 bottom sides of every triangle if you rotate it. So you can do the altitude from the bottom here. You can also do the altitude from that side. If you made the left side become the bottom, if you rotate it around, that would be the altitude, kind of like that. And you can do the altitude here also. So you can draw in all those altitudes. So the most unique part of a altitudes is that if you have an obtuse triangle, when you find the height, it actually goes outside the triangle. The height has to be outside the triangle because you have to go straight down, and that's not even inside the triangle. Or if it's a right triangle, it's actually on the side. Your altitude is one of the sides. Your third altitude would be like over here. If you did all of the altitudes, you get this thing called the orthocenter. In my opinion, it's the least interesting, but still another center. So to get the altitudes, this construction is kind of hard, because you have to find the perpendicular, not through the midpoint, but you have to find the perpendicular that goes to the vertex. Construction is definitely the hardest. So the first thing that we're going to do is get your compass. Pick a vertex that you want your first altitude to go to. Let's do this one on the bottom left. And now you just need to stretch your compass further than the opposite side. So here's the opposite side. We need to stretch it past that. We did this when we did the construction for a perpendicular line through a given point. When we had, here's a line, here's a point, and we had to do a perpendicular line that goes through that point. You put your compass on the point, stretch it past, and make the arc that touches that line twice. That's the same thing we're doing here. So you stretch your compass past that opposite side and draw a circle that touches that opposite line 2 times. That gives you 2 points. From those 2 points, we do that football construction. We have to stretch it more than halfway to our other point, and then do the exact same from that second point. So that should create a perpendicular line. Whoops. And it should go through that vertex. And it should be perpendicular. Looks like it. So now we got to do another side. We just did the one on the right. Now we can do so the one on the right came from this vertex. We're going to pick a different vertex to start from. Let's start from the top vertex. So you got to stretch it past this opposite side, and it has to touch twice. That's where it gets tricky. It doesn't touch it twice. It only touches it once. Because this is an obtuse triangle, it's going to be outside the circle. So what we're going to do is extend this side. Got to draw it further. Extend it out. Use your straight edge. Draw it out further. And that gives you 2 points. So from each of these 2 blue points that I just drew, we're now going to do the construction for the perpendicular line, which is that football construction. Stretch it more than halfway from one blue point to the other blue point we just made, like that. And we're going to make that football type shape. So we get the perpendicular line. That perpendicular line should go straight up to our vertex. Yeah, that's pretty good. And it should have also made a 90-degree angle right there. Looks like it. Now we're going to do the same thing, but from our third vertex. We have not yet done this vertex. Nope, we just did that one. We haven't done this vertex here. Yes, we did. This one. So from that point, you get a lot of lines. You got to keep it really, it's tough to keep straight. Stretch it out more than to the opposite side. The opposite side is right here. This is the triangle, the original triangle. So you got to stretch it past that. And it doesn't touch twice because that side is too short. So you got to extend it out. So you can see your 2 points. Right here and here. So from there you can find your third altitude. Stretch it more than halfway, make your football shape. And that, whoops, will connect up to your vertex. And it's perpendicular to that third side. So your triangle, originally was right here. So our altitudes, we just found 3 of them. Our altitudes, I'll highlight them a little bit different. Here's one altitude. The other altitude is right here. And the third altitude right there. And if I extended this one out like I just did, they all intersect right there. That's the point of concurrency, which means that point right there is the orthocenter. Orthocenter.